the first type of problem. All right. Here we have like bases on an exponential equation. All right. And then we notice that it says b to the m is equal to the n to the b to the n, which means essentially we can just pull those b and n's out like it was a ladder. The m and the n drop down and can be equal to one another. And then we just solve that. And in this case, it's kind of a trivial thing. We're not really solving anything, but it's just to show you how it works. All right, here's one, A. It says solve 5 to the 3x minus 6 power is equal to 125. Now, the way these stand, they don't have a like base, but this side over here can be written as 5 cubed. 5 times 5 is 25. 25 times 5 gives us 125. All right. Now, since these bases are alike, we just yank them out. The 3x minus 6 falls down, and 3 falls down, and we got just a plain old equation. So 3x minus 6 is equal to 3. Add 6 to both sides. We get 3x equal to 9, divide by 3, and that gives us the solution of 3. And you can kind of check it back in here. It would be 3 times 3 is 9. 9 minus 6 is 3. 5 cubed is equal to 125. All right, now on the B one, neither one of these have a like base, but 8 and 4 are both powers of 2. In other words, 2 or 8 is 2 cubed, and 4 is 2 squared. Now, using the power rule from algebra, when we're dealing with exponents, we can then take the 8, right, it's 2 cubed, then I have parentheses, x to the, everything in the parentheses to the x plus 2, but the way the power rule works is we multiply the 3 times the x plus 2. All right, same thing over here. It's going to be 2 times x minus 3. Now that the bases are the same, we're simply going to drop the 2's, and we're left with 3 times x plus 2, 2 times x minus 3. So this simplifies as 3x plus 6. The right simplifies as 2x minus 6. And then we solve for x. Subtract 2x, we get x. Subtract 6, we get negative 12. So there's a solution. And again, you can check it, and if we put it in there, we would have 8 to the negative. This was going to be a little bit hard to figure out. Negative 12 plus 2 would be negative 10. And then 4 to the negative 15. Anyway, I'll leave that checking for another time. I'm just going to go through the principles. Okay. Now we can use logarithms to solve exponential equations. Isolate the exponential expression. All right, take the common log of both sides of the equation for base 10. Take the natural logarithm on both sides of the equation if you got bases other than 10. Remember, the common log means base 10, so those two automatically undo one another. So if you have any other base, you use the natural log. And then you'll simplify using one of these properties. Remember, like for example, in this, ln of e means these two undo one another, and you've got an x there. Same thing with here. That's just going to give you x because this is log base 10. to the 10 is going to give you x, and then solve. So let's look. Now with this one here, 5 to the x is equal to 134. There is no possible way that we can write these with the same bases. So we're going to be forced into using logarithms to do it. All right. So just like any equation, basically, if you do the same thing to both sides, you still have an equation. So we take the natural log of both sides. And the reason why they use natural log is because this wasn't base 10. If it had been base 10, then we could have used the common log. And it really would be a little bit simpler, but anyway. So ln of 5 to the x is equal to ln to the 134. And you'll see that x right here has this multiplier of ln 5. So if we divide both sides by ln 5, here it just leaves us with x, and then it's equal to ln of 134 over ln of 5. And again, you can approximate it as 3.04. Just watch what's being asked for in your instructions, because of the fact that if it says the exact answer, then you would use this. If it says the approximation, you would use this. You know, like approximate to 2 decimal places. Then that's what you would use right there. That last one. All right, now here's one that's got log base 10. Now, on this side, see, what happens is the log base 10 undoes that 10, and we're just left with x. Now, on the right side, there's no way we can simplify it, so it's just log of 8,000. So the log of 8,000 so that's the 3.90 rounded off to 2 decimal places. All right. All right, solving an exponential equation, okay? Again, same kind of situation. We've got x's in the numerator, in the exponent, and these bases don't match, so we can't really just drop the bases because there's no hope of writing 3 and 7 with the same base. So we're going to just take the natural log of both sides. All right, so that's what happens here. The logarithm of the natural log of 3 to the 2x minus 1 is equal to the natural log of 7 to the x plus 1. Now, what they're doing in this next step is they're using that power rule. In other words, the 2x minus 1 times the ln of 3 is equal to x plus 1 times ln of 7. All right, both sides using the power rule. Now, distribute. Multiply ln of 3 times 2x, and you get that. ln 3 times -1, negative ln 3. Now, on the right-hand side, doing the same thing. X times ln of 7 and ln 7 times 1. Now, what we want to do is we want to take and put the x terms, the ones that have x on one side, and then the other ones with no x are going to go on the right side. So that's why they subtract this one here, and thus it appears right there. they add this, the opposite of ln3, and that's why it ends up over here positive. Now that x is a factor of both of those, you can factor it out from both using just pulling that x out, which leaves you with 2 ln3 minus ln7. And then if you divide both sides by that, in other words, when you divide it on this side, it's gone, but over here, and just get plain old x, but on the right side, it comes into this, and you got to approximate it. And just kind of on a calculator, this is how I would suggest doing it. I may have showed you this, but on a calculator that doesn't input, you can't input parentheses. This is the only way I know how to do it. You got to take, I got to make it bigger because the ln doesn't show up unless I do that. So there's ln3, and I'm going to times it times 2 minus 7 ln is equal to, so that should be our denominator. And then up here, it doesn't matter about the order you do it because it's addition. Remember, the reason why I have to stow that is because with division, I got to divide denominator and numerator. I can't flip-flop it. With addition or multiplication, it doesn't matter. Let's see if I can get this thing big enough to where that, there it goes. So 3 ln 3 ln plus 7 ln. There we go. And then divided by memory recall equals to 12.11. All right. So you got to remember about that. And even if you have parentheses that, I mean, a calculator that accepts parentheses, you got to remember to follow your order of operations, because if you don't, the calculator will. You got to make sure that it does. All right, any questions about that one? All right, the definition of a logarithm is basically, we can take that logarithm like this and write it as an exponent. In other words, log base b of m is equal to c. Well, this means b to this power is equal to that m. Solve. Now, with these, it's important, we got to check for the solution, because since we're going back to logarithms, there's a chance that something may not work correctly, and I'll show you what I mean. Log base 2 of x minus 4 is equal to 3. Okay, so we just use the definition of the logarithm by writing it as an exponent. So it's base 2. So 2 to this power, and the power is the one that's on its by itself on there with equal on the other side of the equal sign. Cubed is equal to x minus 4. 2 cubed is 8, and then we add 4, and we got x equal to 12. So we need to check this back into the original equation, because whenever we use that inverse property, it can sometimes cause issues. And let's just say this right here, if we were to solve x minus 4 is greater than or equal to 0, 4 is the lowest it could be. You can't make it any lower than that or else it's going to be negative. All right, so 12 minus 4 gives us 8. The log base 2 of 8 is equal to 3. So this is 3 is equal to 3. So it works. All right, so let's look at another one. Here we got 4 ln of 3x is equal to 8. So we're going to remember, first of all, divide, so this is a multiplier of this. We're going to divide both sides by 4. So 4 divided by 4 is just 1 ln x to ln to 3x, and 4 into 8 goes twice. So that's where that comes from. All right, now that's used, and since we've got it established as a log equal to something, then this is going to be our power, and the base is e for the natural logarithm. So e squared is equal to this of 3x. Then to solve for x, we just divide both sides by 3. And that's e squared divided by 3. All right, and that's an exact value, but they put it in here and it works out just fine. I'm gonna check it. Any questions about that one? All right. So we got a log of x plus the log of x minus 3 is equal to 1. So what we're going to use is our logarithmic properties from a couple of sections back to condense this. We're going to condense it, and then we'll use the definition of the logarithm to put it into an exponent. All right, so these are being added like bases. So we're going to multiply x times x minus 3 and the log of that. Okay. Now that it's in a single logarithm, then this is log base 10. So 10 to the first power is equal to that. See, there's the power. The base is understood to be 10 there. When there's not one, it means the common log. So 10 to the first power is equal to x times x minus 3. Distribute that and then subtract 10. And we've got a factorable equation, a quadratic equation. So that means x minus 5 is equal to 0 means x is equal to 5. X plus 2 is equal to 0. X is equal to negative 2. All right. All right, so let's move on. Let's see, because we're going to have to check both of these. Remember, when you go from a logarithm to an exponential function, you want to check the solutions, especially because some of these could be outside the boundary, even though the mathematics was done correctly in the calculation. All right, so we're checking 5. So we put 5 minus 3 in there and 5 in there. So log of 5 plus log of 2 is equal to 1. Again, we can use the condensation of the product rule. 5 times 2 is going to be 10, so the log of 10, and on this side we're just a 1. Well, remember, that means 10 to the what power is equal to 10, and that is correct, because this would be equal to 1. So that's fine. But on the right side, we got a problem now. Check -2. So log of -2, that's a problem. And it also becomes a problem over here because it's -2 minus 3 gives us -5. And just to show you what would happen, without invalid input. If the input is negative, then we got an issue. Okay. So same thing is going to happen with 5 negative. So the only solution is 5. Okay. All right, now this one-to-one property is very similar to the first property we started with, except this is for logarithms. So express the equation in the form log b of m is equal to log b of b. So they both have to have the same base, same type of logarithm. Okay, coefficient's got to be 1. In other words, what's multiplying it? Use the one-to-one property, rewrite the equation in this form. And then we've got m is equal to n, and very similar to the first property. That's the first type of equation. All right, so ln of x minus 3 is equal to ln of 7x minus 23 minus ln of x plus 1. So again, if we can condense, then we do it. This side can be condensed into one natural logarithm because they're the same base. I'm sorry, the same logarithm, which means the same base. And so this is negative, so it's 7x minus 23 over x plus 1 written as 1 exponent. All right, now, what are we doing once we get it like this? Well, now it's got a rational term in here. In other words, this one is fractional. So rather than deal with that and try to figure out what to do, we're just going to multiply by that LCD, which is x plus 1. When we multiply on this side, we're multiplying the x minus 3. On the right side, we're multiplying all of this times x plus 1. So see, those go away, and you're just left with a numerator of x minus 23. And over here, that can be FOILed out as x squared minus 2x minus 3, and that's equal to 7x minus 23. Then subtract 7x from negative 2x is negative 9x. Negative 3 plus 23 is 20. So then it's x minus 5 times x minus 4. And then two solutions. Checking both of them. 5 goes in, you got to put it in each one of the spots that there's an x. 5 minus 3 is 2. Here it's 35 minus 23, which is 12. And over here it's 5 plus 1 is 6. You can combine these together again, condensing using the quotient rule. ln of 12 over 6 is equal to ln of 2, and they're both exactly alike. So that is a solution. Same thing with 4. 4 minus 3 gives us 1. 4 times 7, 28, minus 23 gives us 5. And then here, The negative ln of 4 plus 1 is also 5. We can put these together. But just, I'm just going to point something out here. See, the ln of 1 is 0. So in essence, right here, you could have just subtracted those, and that would have been 0, and you could have declared that it was a true solution right after that, because ln of 1 is 0. But I mean, the good thing about math, you can't break it, even if you take a longer path that need be. All right, let's look at just how this plays into applications. It's not going to really play any different because these things are just the same kind of equations. All right, it says, how long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% interest compounding quarterly? So we're using just the simple interest form, and we're filling in. Remember, it's compounded quarterly, so n is going to be 4, both here and here. It's 0.08 as a decimal, the 8%. And then the principal we're starting with is $1,000, so it replaces that, is equal to 3,600. All right, and then this ends up being 4t. You still got a t in there because we don't know what the time is. We're solving for the time. So let's just whittle this down as much as we can. 0.08 divided by 4 is 0.02. 1 plus 0.02 is, of course, 1.02. And then when we got this, if we divide both sides by 1,000, on the right-hand side, it's just going to leave us with 1.02, but $3.6. All right, now we just going to do the ln of both sides because there's no base 10 here. So the ln of 3.6 is equal to ln of 1.02 to the 4t power. Bring the 4 down as a multiplier with the power rule. There's the t you want to solve for. So we need to divide by 4 and ln 102. So on the right side, everything is going away but the t. And on this side, it's the 4 ln 102. And then if you, again, if you solve that, let's just go through and do it. Times 4 and then 3.6. 16.17, which is 16.2. So it'll take a little over 16 years to get that $3,600 at 8% interest. Boy, I'm having a hard time waking up this morning. All right. Another application, this is one that we've seen before, except it's going backwards. We got the percentage of adult height attained by a girl who is 2 years old can be modeled. F of x is equal to 62 plus 35 times the logarithm of x minus 4, where x represents the girl's age from 5 to 15. All right, f of x represents the percentage of her adult height. At what age has a girl attained 97%? So f of x is the percentage, so we're going to just replace that with f of x. We use 97 there. And then the 62 plus 35 log of x minus 4 stays the same because we don't have anything to put in there. The only thing we need to do is to get that x out of captivity and find out what it's equal to. All right, so the first thing is subtract 62 from both sides. All right, you got 97 is equal to 35. And then there was this 35 was already there. And so when we divide both sides by 35, on the right-hand side, the 35 is just log x minus 4. On the left-hand side, 35 divided by 35 is 1. So now we got to use, well, since it's a common log, we can take and use base 10 to undo this right-hand side and get the x minus 4 out. And then when we do it over here, it's 10 to the first power, which is equal to this 10. So add 4 gives you 14. So at age 14, she's attained 97% of her adult height. Okay. So let's go over to the board and look at some problems. And I just got various ones to take us through here. So I've got this one's from the back of the book. All of these in here, they're going to want us to solve them. So that should hold for everything. It's just a matter of the method. 5 to the x is equal to 625. So these have no hope as they are because they don't have a like base. We could use the another method, but let's just, since we can, this kind of right here can be written as five to the fourth. And now the bases are like, so we got simply x is equal to 4. Okay. Pretty darn simple on that one. Okay, again, we got 5 here, so there'll hopefully be a hint that this one can be written as 5. Cubed. All right, just to kind of get your brain stirring. See, 5 times 5 is 25, and times another one, That's how we get to 125. And before we had another one, and that's how we got 625. All right, so now they're like bases, and we just simply said 3x minus 1 is equal to 3. So then this is going to be 3x is equal to 4. So x is equal to 4/3. Okay. All right, here's an interesting one. 9 of x, oops, 9 to the x is equal to the cube root of 3. All right, now as it stands is we can't write these with the same base, but let's just do a little bit of chipping away on that. First of all, I see a 3 in there, and that I know this can be written exponentially because of the exponent rule. And this over here can be 3 squared. So that's 3 squared. And right here, this is 3 to the negative 1/3. All right, remember, and then because it's in a denominator, that means negative, because the negative means take the reciprocal. So this right here is that written with exponents. So let's go over here. So that's 3 to the 2x is equal to 3 to the negative 1/3. So now that we have the black bases, we can just go 2x is equal to negative 1/3. Divide by both sides by 2, or multiply both sides by 1/2. Negative 1/6. Okay. Let's see. How about let's do a little something different with the bases. E to the x is equal to all right, so what we're going to do is we're going to take a natural logarithm of both sides, because if we take the natural log over here, we're going to lose the E because those undo one another. And then on the right side, well, we're just going to use that as an approximation. All right, so these two undo one another. So X is equal to ln of 0 so that's approximately equal to negative 0.186. Okay. So e to the 1 minus 86 is equal to 79. Again, we're going to do the ln to get that outside, to get that out. So these do undo one another, and we got 1 minus 8x is equal to hold on a second. I think I left something off on that problem. Let me go back and check. Oh, wrong way. So it's 7957. Okay. I thought that's what I had, but I wanted to make sure I hadn't. I miswritten that. Okay, I miswrote that. Okay, so 1 minus 8x is equal to ln. All right, so we don't need the 1 over here. All right, but we still got negative 8x. And then we're going to both divide both sides by negative 8. So x So there we go. Okay. All right, we'll just do a couple more here. This was a little bit different. All right, so this one is 3 x over 7 is equal to 0.2. All right, so if we take the ln of both sides, so then I'm going to take this and use the power rule to put it in front. All right, now what I'm going to do is I'm going to multiply both sides by 7, and that's going to make this disappear. In other words, I'm multiplying by 7 over 1 and 7 here. So I'm going to have x ln of 3 is equal to 7 all right, and then I can just divide both sides by ln 3. So x is equal to 7 ln of 0.2 over ln of 5. And that approximates out to about -10. -10.25. All right. Let's see. All right, here's one that's going to have a lot of little pieces to it. And then this is the last type where we'll have to check, because we're going from a logarithm equation. And we're going to try to do it exponentially. All right, now this is plus, so that means we're going to put it together into one base. I'm sorry, one logarithm multiplying. All right, so I got one to each side. So now we can do essentially what we did in the first problem, which is just go backwards, since these are both, this is what they call the one-to-one property. Both logs are the same on each side. So we can just set each equal to one another. Well, let's tell you what, let's run that through on the right-hand side. You can do it afterwards, but so now, essentially what we're doing is we're taking the common log of, we're taking the base 10 of both sides. Like I said, that's what the that one property means, then means you're left with just the input of the logarithm equal to one another. All right, and so we're going to solve that. -1 is equal to x. So let's subtract 2x. All right, so now, and then subtracting 10. I'm sorry, subtracting 9. So that means x is equal to -10. Now, remember, since we I started out with a logarithmic equation, we got to check it in the original one. I think this was like 60 or something. I'm not sure. I got to write it down. But anyway, let's go ahead and check. This is where it's crucial when we're solving a logarithmic equation. Put it back into the original. All right, so watch what's going to happen. I mean, this right here is not an issue because nothing changed, but right here, we got log of -21 in there. And on this one, we got log of -7. All right, so what happens then when we do 21 negative and then try to take the log? See, again, it's an invalid input. Anytime that input is negative, we can't take the logarithm of it. So what it means is no solution. All right, any questions? All right, that's probably enough for that section. We just got one more section. I almost would have hurried through and covered it today, and then we could take off, but you know, I can't just cancel class willy-nilly. So anyway, so we'll finish up on Thursday. Tuesday will be a review, and then we'll go from there. We'll have our next test, remember, before Thanksgiving. Okay, so it'll be running out like on Tuesday. On Thursday, I'll check the dates and we'll see. It may open up on the weekend. I'm pretty sure that's what I'll have it, and I'll have it closed on the 23rd. If you so desire, I can probably even stretch it out to the 24th, because the 24th is a Monday and usually there's no school. But they made that day optional because of the storm. So anyway, if you got any questions, stick around. Alicia, I wanted to talk to you about that issue you brought up, so stick around for me.
Thank you.
Okay, bye-bye.
Yeah, Mr. Cruz, I'm here.
Okay, I went in and looked at some other students and I didn't see the same issue, but I could not see any difference in what you put in. So I put in a request of support. If you do the same thing, we might be likely to get some kind of response. I assume it's something that we're not seeing, but like I said, I checked on another student that had done it and they had all of them worked out correctly and I didn't see any difference. So I mean, if it's an issue we're not seeing, it's confined to you, so it'd be a good idea to find out what it is. So I would just if you go in, let me just show you how you do it. Well, it's not that hard to do, but you just do it. I think when you do that, it sends them the problem.
Yeah, you know how like you type log in, it just come in bold. Like it's not doing that.
Well, like I said, it is, but I don't see why it would just be doing it to yours. So
yeah.
So
that's why I was saying I'm not sure if it's the type of computer I have or I'm not even sure.
That would have to do with it. I mean, it just might be. But like I said, it's like go on one of them that's bad. I mean, there's nothing wrong with on that one. I mean, that one's probably not the best one to do. I would, what I would do is go on, you know, I don't know, maybe.
And it did the same thing for 4.3E. Yeah, it did the same thing for 4.3.
What I would do is, okay, that's not good. Just do this. Where's the thing at? Oh, ask publisher. Just do this, like put in there, you know, why is this problem wrong?
Okay.
My teacher doesn't see an issue. So do that and then see what they say.
Okay.
It is. I don't see anything. And like I said, I could just go in there and just give you credit for them because I don't see a problem. But the thing is, if it's something peculiar to you, and then when you take the test, you don't want that to happen, okay?
Yeah, I don't want to get my questions wrong because it's some
Like
type
I
of
said,
error.
I can, give you the half point there, but like I said but I want to find out why it's doing it.
Right.
Because I don't see any issue. I mean, is it a space or what? Like I said, and then you can get it straight from them. So if there's an issue, they can fix it, or if it's just something that we're not seeing, you know what to do, okay?
Okay, I'm gonna let you know
Just do
then.
that, and like I said, and then just go on with the rest of the work. Because like I said, I don't see any issue with what you're doing.
Okay, then. Well, thank you, Mr. Cruz, and I'll keep you updated.
All right. Bye-bye. Thanks.
Have a nice day.
You too.